So in this last problem here, we saw this idea of a complement. That complement was 100% minus the percent that we were given in the problem, which was the 4%, to get what was left over, 96%. And this actually happens quite a bit. It's called a percent decrease problem, or sometimes called a discount problem. If you're in a business, a lot of times you get something called a trade discount. This typically will occur with a place that sells both directly to consumers and then also to retailers. So if you're a retail shop where you're going to buy this and have to resell it to consumers, in order to make a living, you're going to have to get this at a lower price than what the company would sell it directly to a consumer. So you might get a 12% trade discount. So that means you pay 12% less than somebody off the street would pay. So if you want to buy, or you purchase items with list price of $800. List price just means full price. So the question here is, how much do you pay? Well, we could go ahead and find that 12%. 12% is 12 out of 100. 800 is the whole amount. If we cross multiply and divide here, 12 times 800 divided by 100, we do get $96. But if you recall, what we're looking at here, the 12% represented the amount of the discount. We want to know how much we paid. That's going to be found by taking the full $800, subtracting the $96 discount, and getting that we paid $704. Now I left myself some space here because I'm going to fill some things in. So there's a basic formula here where we can look at this and say list price or full amount minus the discount equals what we paid. And in a percent problem, every item is described by two numbers. In this case, these are dollar amounts. Of course, the other side, the other number that describes them are percents. In the problem, we are given 12% discount for the trade discount. So we put 12 in for the discount. Now we look at it, it looks like that's all that's given, but there's always one other piece of information in a percent problem, and that's 100%, the whole amount or the base amount, what the calculation is being based off of. In other words, whatever is represented by the number that would normally go here. Here, that base amount is the full amount or the starting price. That's the 100%. And we are subtracting here. So the amount paid would be 100% minus 12%, or 88%. So what we could have done, instead of finding 12% and subtracting it out, is we could have found 88% of 800. And if we set that up and we cross multiplied and divided, 88 times 800 divided by 100, we would have got $704. And that's an example of that complement. If 12% is the discount, the complement, or 100 minus 12, is the amount paid, 88%. Now in this case, it's probably about the same amount of effort to go either way. You could find the 12% and then subtract it out, Or you could subtract from 100 to get the complement and find the complement as your percent. But there are some problems out there where you have to use the complement. For example, after a 30% discount, you pay $259. I want to know, how much did you save? In your notes, try to do this one quick. I want to see what you come up with. So if we start with the original 30% here, 30 out of 100. 30% represents the discount. 100 represents the full price, the list price, however you want to describe it. Over here, we have the $259, and we want to know how much you saved. So on the other side, we're going to have two things, a known number and something we're looking for. Well, what are we looking for? How much did you save? That represents the amount of the discount. That represents this number right here. So that must mean we put the $259 down here, right? Say no. No. Because the $259 represents the amount paid after the discount. This is the full price. The 100% represents the full price. What percent represents the amount paid after the discount? Well, that would be the complement. 100% is the full price minus the 30% for the discount means 70% is the amount paid after the discount. So if we set that up with 70%, the $259 goes on top or bottom? Top. Because that's the amount paid after the discount, which is represented by the 70%. I can actually fill in the numbers over here. I got the $259 right here represents the amount paid after the discount. So that tells us the $259 always has to stick with the 70. If we cross multiply and divide here, 100 times 259 divided by 70, we get $370. Is that the amount we saved? Is that what we're looking for? No, that's 100%. 100% is the full price. So the 370 represents the full price here. So you put 370 goes there. How do we find the amount we saved? Yeah, we subtract it. Oops. We saved $111. That's our 30%. So you do have to be very careful with these to know what it is you're given, what does each of them represent, what percents match up with what, and then once you find it, what did you actually calculate, and is that what you were looking for? In fact, I actually do a lot of it with these tables, just like this. I actually fill up the whole table and use it to calculate. I'll do this one out for you. And it doesn't matter what words you use. You can have full price, you can have list price, starting price, whatever. Minus discount. Down here you can put price paid, price after discount, whatever words you want to use can go down here. And each item, as we said before, has to be represented by two things. One of them, or two numbers. One of them has to be a percent, and in this case, the other side is dollars. It could be other things. We know the discount is 30%. So I put in 30% there. Full price, or the starting amount, is the full amount, or 100%. We can subtract 100 minus 30, tells us the price we paid is 70%. of that starting amount. Then we're also given the $259 is what we paid afterwards. What we're looking for here is the amount we saved, which is the amount of the discount. What that's telling us is we don't need this top line. Why don't I need it? Well, what I need is two things. I need the line that has what we're looking for. In this case, that's the discount. And we need the line that has both numbers. That's the price paid. We have the 70 and the 259. I could pull them out and make a proportion, or I can just leave them right where they're at and cross multiply and divide right there. These two are diagonal. The 30 and the 259 are diagonal. I multiply those together and divide by the 70, which does give me $111 as my discount. I like setting things up in a table like that. For those of you that are going to go on to take Math with Business Applications, that table shows up in a lot of different ways when you start doing markups based on cost, markups based on selling price, discounts, perishable goods, stuff like that. That table comes up a lot because we deal with a lot of percent increases and percent decreases. So let's say that Tim reduced his downtime all today by 7% to 46.5 minutes per day. How many minutes of productivity does Tim have? So we're looking at this. We have Tim's whole day, his whole shift, or however you want to look at it. Whole day minus the downtime gives us productive time. So again, I'll put percents over here. Over here, it's going to be minutes. What do I know? Well, 7%, where's that going to go? Downtime. Percentage of downtime. Do I know any other percents? There's always one that's hidden. It is the 100, and it's going to go where? The whole day. That's the whole thing is 100%. So what percent goes in for productivity, or productive time? 93%. On the other side, the only minutes we have is the 46.5 minutes. Where does that go? Is downtime. Yeah, downtime is reduced to 46.5 minutes per day. So that goes there. What are we asked to find? Productive time, right here. So that's telling us we do not need the top row again here. We're going to cross multiply. This time it goes a different direction, but it's still diagonal. 93 times 46.5 divided by 7. $617.79, we'll call it. Minutes of productive time. This is one that without a table like that, I would have a really hard time figuring out where to even begin on the thing. Okay, well, let's look at the other side of it. This is a percent decrease, or something's been reduced. Let's look at where there's a markup or a shipping cost or some sort of a percent increase. Let's say that FLM charges 8% for shipping and handling. How much is the total charge for items priced $250? So again here, we got 8%. 8% represents the shipping and handling. And the 100% represents the beginning price, starting amount. And we can find that 8% of the 250. 8 times 250 divided by 100 is 20 bucks. But again, that's not our answer. We're asked for what's the total charge. So it would be the $250 plus the $20 to get a total charge of $270. Now again, this fits into that same type of table. So we have the list price, our beginning price, or however you want to do it, plus our shipping and handling charge to get a total charge or total price. And again, each item is described by two numbers, a percent and then another number. In this case, that other number is dollars. We're given the 8% for shipping and handling, but again, we have 100%, which is the beginning amount or the list price. Is it going to be 100 minus 8? No, because the shipping and handling is not subtracted. It's not a discount. It's a markup. It's an add-on. So it's 100 plus 8. What we pay, our total charge is 108%. So what we could have done here was we could have found 108% of the $250. And if we cross multiplied and divided there, 108 times 250 divided by 100 would have given us the $270 directly. Now again, here's one where finding that 8%, finding the $20 and adding it on is just as simple as adding the 8% to 100% and finding 108%. But there are going to be problems where we cannot do that. Let's say after 9% tax, a hotel room costs $272.50. How much tax was charged? I'm going to try this one in your notes again quick. See what you come up with. So if we look at this one, we've got 9%. But when we look at it closely, the 9%, the 9 represents the tax. The 100 represents the beginning price. What we have here, the $272.50, is the price after tax. So that doesn't represent either of those values. So if we look at this as price before tax plus tax gives us the price after tax. And again, each of those is described by two numbers. The $272.50 is the price after tax. Then we have the 9%, which represents the tax. What else do we have? $100 is the before tax. It's the whole amount before tax. So now we can go ahead and do 100 plus 9, because when we do tax, we add it on. This 109% is the after tax. So we're looking at how much tax was charged. We're looking for this number right here. So I don't need the top row. So I can cross multiply and divide right in here. 9 times 272.50 divided by 109. Gives us $22.50 in tax. What do you think? We will look at percent increases and decreases a little bit more next class because it is a very tricky topic and it's one that takes some time to get used to. There is a new quiz tonight. That is due Wednesday, 11:59 p.m. There's new homework. It'll be due Thursday. Unit 3 test, I'm going to push back to next Tuesday because I wanted to take a little more time on these percents. So Unit 3 test will be next Tuesday.
So when I'm going